Hi, this is Miss Lee again, and this is our fifth lesson for indices and surds. Okay, so today we are going to learn a new rule for simplifying surds, which is called rationalizing surds. Okay, so later we will go deeper into what is rationalizing, but before we can rationalize a surd, you have to first learn what is conjugate surds. Okay. So when the product of two sets, two brackets, okay, with sets, okay, where they have the same set, but there is a difference in the sign, okay, we will call them conjugate sets. Okay, so some example of conjugate sets is like A, okay, or even simpler ones, square root 2 minus square root 3 and square root 2 plus square root 3. Okay, so these are conjugate sets. Now how about this one? 2 square root 2 plus 4 square root 3 is conjugate with 2 square root 2 minus 4 square root 3. So basically the terms are the same. It's just that the sign is opposite. Okay, one is plus, the other one is minus. Now because of the difference in sign in the conjugate sets, okay, therefore when we are to expand them together or multiply them and expand, notice that they will be in the form of a plus b, a minus b. So if I were to expand them, I can use the algebra identity a squared minus b squared. And so I will get 4 times 3 minus 16 times 5. And if I were to evaluate, I will get negative 68. So a special property of the conjugate set is that if you were to multiply them together, you will obtain an integer without surds. Okay? So talk about rationalizing. It is the word rationalize means to make irrational into rational. Okay? So rationalizing denominators is to remove the surd from the denominator. Okay? So let me give you some examples. Okay, later we will see more questions, but example, let's say I have 1 over square root 3. Okay, to simplify further means I have to rationalize the denominator. That means I have to make the denominator into an integer by multiplying something on top and below so that the surd will be removed. Okay, now but this is the easy case with just a one surd. What if, okay, instead of this I have okay, what I have is 1 over 2 minus square root 3. Okay. So this is also considered not simplified. And I have to multiply something on top and below such that the surd at the denominator can be rationalized. Okay, so what exactly is this trick that we're going to use in order for us to remove the surd from our denominator? Okay, is to apply conjugate surds. Okay, now let's look at an easy case first. Let's say I have 1 over square root 2. So in order for me to not have surds at the denominator, I can multiply it with square root 2 again. So square root 2 times square root 2 will give me 2. Okay, but it is not fair to the question that I just multiply square root 2 to the denominator, because this is not the same as the start of the question. So I have to multiply both on the numerator and the denominator, okay, so that if I cancel them, it will go back to the question. Okay, but in this case, okay, I want to make use of the newly introduced square root 2 on top at the numerator and the denominator, okay, so that my denominator will become square root 2 times square root 2, which is 2, and on top I will get square root 2. Now, you can always check using the calculator again, okay, by evaluating 1 over square root 2 on a calculator and the answer on a calculator, and this is the check that you have rationalized correctly. Okay, so a rationalized result, the denominator will not have surds anymore. Okay, no more surds at denominator. Okay, that is the whole point of this further simplification of surds. Okay. Now let's look at some example questions. So if I have a 6 over square root 3, okay, how do I rationalize is to multiply square root 3 to both the top and the bottom, numerator and denominator, and I will get 6 square root 3 over 3. Okay, but please check that you can still simplify. So I'm going to get 2 square root 3. Okay, please check on the calculator that 2 square root 3 is the same as 6 over square root 3. Okay, now we're going to look at a fraction that is a little bit more complicated now, because now the denominator has, okay, plus minus 3 minus 2 square root 3 is no longer just a square root 3. So in order for me to rationalize such a denominator, I will have to make use of the conjugate property, okay, its conjugate surd. So, okay, what I can do is to make use of the conjugate surd property and multiply both the top and below again. Okay, you have to do this to both top and bottom, okay, so that it's fair, okay, to the start of the question. So if I were to do this, okay, what will happen is that my numerator, okay, I can just leave it as 9 times 3 plus 2 square root 3 first, but the bottom, see that it's now a minus b, a plus b form, right? Okay, so I can write it as a squared minus b squared, okay, and because of the squaring of the surd at the bottom, 2 times square root 3, okay, then the whole thing square is going to give me 4 times 3, which is 12. Okay, so I can simplify the denominator more to get negative 3, and I can simplify again to get negative 3 plus 2 square root 3. Okay, now you can leave your answer in this way, or okay, you can choose to expand it further. Okay. So you can always check your answer again. Okay, by now you should know how. Okay, now how about part C? What should you multiply on top and below? Okay, notice that when I were to introduce a conjugate surd, I will also bracket the denominator that is at the question. Okay, it's the entire thing that multiplies with the conjugate surd. Now the next question is, what is the conjugate surd for this case? Okay, look at the sign, look at the terms. So the conjugate will be square root 3 minus 2. So on top will be square root 3 minus 2 multiplied to 2 as well. Okay, so if I were to simplify the denominator, okay, simplify the denominator first so that it will end up with an integer, okay, and then you can see whether it can be cancelled with the factor that is at the numerator. Okay, so if I were to simplify the denominator again, we have gotten 3 minus 4, negative 1. Okay, so if I were to rewrite this, I can simplify it to become negative 2 times square root 3, negative 2 times negative 2. Okay, simplify. Okay. Now, how about in this case where there is both surds at the numerator and the denominator? Don't worry, you can still do the same. Okay, when it comes to rationalizing, it's okay for the numerator to have surds. It's just the denominator. It's just the denominator to be rationalized. Okay, it's okay for our numerator to have surds. Okay, so in this case, okay, it's just the denominator that I have to multiply, to have to take care, okay, to make it rationalized. But the top cannot be neglected. Okay, so I still have to do the same like just now for example 1. Okay, so in this case I will get square root 3 minus 3, square root 3 plus 1 on top. Below is my a minus b, a plus b, which is my a square minus b square. Okay, and now if I were to rewrite the denominator, I will have gotten a very nice 3 minus 1, which is 2. Okay, but you have to simplify the numerator as well in this case, because we never know whether we can actually still reduce the numerator and denominator by a factor of 2. Okay, so we're going to expand the numerator. Square root 3 times square root 3 is 3. Okay, negative 3 times square root 3, and so on. So in the end, 3 minus 3, I will get 0. Minus 3 square root 3 plus square root 3, I'll get minus 2 square root 3. And notice that in the end, the final answer is just negative square root 3. Okay. So the steps are pretty much very procedural. It is always just to target your denominator first, okay, to multiply its conjugate. But you cannot just suddenly introduce another bracket. So on top, you also have to do the same, so that it goes back to the original question, okay, to be equal. And then ultimately, it is to use a square minus b square to do a simplifying of the denominator. And of course, to check whether the top can still be simplified and reduced to the fullest. Okay, now I'm going to let you try question 2b, okay? And I'm going to give you the final answer for 2b. And please do this on your own, okay, to see whether you have got the idea of rationalizing. Okay, so know that a rationalized fraction will never have surd at the denominator. It will just be an integer at the denominator. Okay, let's look at further questions on rationalizing. In this case, the difference is that they purposely make it such that it is two fractions that you must simplify first, okay? Whereas just now it was just one fraction, so we can straight away do the conjugate. But right now there are two fractions, so there is unfinished business in the combining, and therefore that is our first step, okay, which is to combine first the two fractions. But in this case, they have different denominator, so I'm going to multiply, okay, their lowest common multiple, so that they have the same denominator. Okay, so the first bracket should be square root 3 minus square root 7. Okay, then the other fraction I will multiply with square root 3 plus square root 7. And then what happened is that since their denominator is the same now, I can combine them. And for the top, okay, because it is 1 times the bracket, so I can just open up the bracket at the same time. and beside this is a plus. Okay, so I can just open up the brackets and then I can simplify. Okay, 2 square root 3 will be my remaining terms for the denominator, for the numerator. And then at the bottom, notice that I have a square, a plus b, a minus b again. Okay, so I can write it as a square minus a b square. Okay, further simplify it all the way, and I'll end up with negative square root 3 over 2. Okay, so you can always check with your calculator. Make sure that the original question, when you evaluate on the calculator, is the same value as the final answer on the calculator. Okay. So for the next question, again, I have two fractions, and in this case, they are already of the same denominator, so I can just combine the numerator on top, okay, into one fraction, and I can simplify a little. Now, what happened is that, notice that the denominator has surd, so I have to do a conjugate, okay? But before you do that, okay, remember the advice that Miss Lee gave you. Keep things small, or keep your numbers small when you simplify. Don't make things complicated for yourself. In this case, there are things that you can reduce first before you go and do your conjugate, which will complicate things a little. Okay, so reduce first wherever you can. So how is it that Miss Lee can notice that there is something to reduce? Okay, look at all the coefficients of the terms. Okay, we have common terms, common factors for numerator and denominator, which is 2, right? Okay, so I can factorize out 2 first, and then I can do a divide of the factors. Sorry. Okay, so now I have a smaller fraction with surd to manage. Okay, 4 plus square root 2 over 2 minus square root 5. And then now I talk about the rationalizing of the denominator, okay, with its conjugate. Okay, just now it's minus, so now I use a plus. Okay, so simplify this by expanding the top, below by expanding the denominator. Sorry, I think I have a mistake here. Okay. So it's please be careful when you do your simplifying. Okay. You can always check with the calculator later. Okay, right now I can simplify the numerator by expanding. Okay. Square root 2 times square root 5 is square root 10. Okay, and below I have a square minus b square. So if I were to simplify, there is actually no common terms anymore. So there is nothing that I can combine. Don't force it, okay? Square root 2, square root 5, that's it. Sorry, okay? But over here, the numerator can be simplified. The denominator can be simplified. I have 4 minus 5, which is a negative 1, okay? This is a negative 1, so I can rewrite as negative 8 minus 2 square root 2, because it's like dividing negative 1 throughout. Okay, since the denominator is a negative 1, so I can simplify to become negative 8 minus 2 square root 2 minus 4 square root 5 minus square root 10. Okay, square root 10 you cannot simplify anymore because I cannot extract, or I cannot find a larger square factor for 10. Okay, so that's it. Okay, if you find your answer suspicious or you have some doubts, okay, you can always check by the calculator, using the calculator to evaluate the question and your answer and make sure that they tally. Okay, so that's all for today's lesson on rationalizing. Next lesson, we will talk about how to solve equations with surds. Okay, thank you.